Note, the following maintenance items are to be performed every 250 hours. To assist in performing a 250-hour service on your helicopter, Rotorway provides a 250-hour kit that includes all the parts required for recommended 250-hour changeout. Call the Rotorway Parts Department for more information. Replace the air filter and clamp with the new filter. Do not substitute the air filter. Use the filter only supplied by Rotorway. At 250 hours, replacement of the cam gear is necessary. Note, some older manuals show the aluminum cam gear as a 500-hour RCO. Mandatory Compliance Bulletin M14, dated January 2, 1997, requires you to change your maintenance manual to 250-hour RCO for the aluminum cam gear. If you received your engine after June of 1999, you may have the new style steel cam gear. If this is the case, verify the engine serial number with Rotorway Customer Service to verify what parts to order. The steel cam gear will remain at 250 RCO. When the aluminum cam gear is replaced with a steel cam gear, it is also necessary to replace the mating gear located on the crankshaft. This procedure can be performed with the engine installed in the helicopter. Removal of the heat shielding will be required. The engine will need to be supported with straps the same way as shown earlier in the maintenance video series when inspecting the rubber ring in the lower engine mount. Disconnect the oil lines and oil temperature sensors from the lower engine mount cover. Be prepared for some oil to drain. Then drain the oil from the lower cover by removing the drain plug. We will demonstrate the rest of this procedure with the engine removed from the helicopter. If you decide to remove the engine from the airframe, refer to the 1,000-hour service interval in the maintenance video series for engine removal procedures. Fabricate an engine bench stand as shown to support the engine while it's on its back side. Remove the 5/16" bolts attaching the lower engine cover to the case. Do not remove the oil pump cover from the lower cover. Leave it bolted together as a unit. Remove the lower cover by using a piece of wood as a pry bar between the oil drain fitting and the engine case on the pilot side and the upper oil line fitting and water jacket on the passenger side. This is necessary to break the silicone seal. Inspect the top part of the oil pump shaft for any signs of wear. Call customer service should you discover any noticeable wear. In the same way as when measuring the valve lash, rotate the engine backwards to position the crank gear key so that it lines up with the front split line of the engine case. The camshaft should now be positioned with the oil pump drive slot pointed approximately at the 11:30 clock position, with one of the 3 attachment bolts positioned towards the front of the engine. If the gears do not line up as described, try rotating the crankshaft gear another 360 degrees. Caution, it is imperative from this point on that the camshaft and crankshaft remain in this position. Even the slightest movement can cause timing problems and possible engine damage. Remove the 5/16" socket head cap screws holding the cam gear to the camshaft, one at a time. Before removing the last bolt, verify that the camshaft and crankshaft have not moved. Carefully remove the cam gear. It should remove without any excess force. During the assembly process of the engine, the crank gear was installed on the end of the crankshaft by heating the gear to expand the bore for a tight fit. A relief hole must be drilled in the crank gear for its removal. Remove the retaining ring from the end of the crankshaft with a couple of screwdrivers. Drill the approximate size hole between the top of the crank key and beveled gear teeth shown here. Usually a 3/16" drill bit. Use extreme caution when drilling the relief hole through the old crank gear, as the main bearing is in close proximity. Use a drill stop to control drill bit depth. Use a caliper to determine the position of the drill stop. Use a piece of shim stock placed between the gear and the bearing to protect the bearing surface. Use a tapered punch to split or crack the old crankshaft gear. Remove the gear and clean the area. Before installing the new crank gear, verify the crankshaft gear key is seated correctly. Inspect to make sure it is positioned to allow the installation of the new gear. For proper installation, the new gear will need to be heated to a temperature between 500 and 800 degrees Fahrenheit. Heat the new crank gear evenly as shown. Look for a color change in the area where the black coating has been removed to be brown or purple in appearance when heated to these temperatures. Quickly position the gear on the end of the crankshaft and seat into position. If the gear becomes too tight before being fully seated, then use a large socket and hammer to lightly tap into position. The keyway slot marked with an O should be the one used to position over the key. Be sure the beveled edge of the gear faces toward the bearing. Modify a pair of snap ring pliers to install a retainer ring. Be sure the ring seats properly. The replacement cam gear can be installed in several different positions. Pick the position where the bolt holes best line up to prevent the camshaft from rotating when tightening the bolts. There must not be any movement of the camshaft as the bolts are tightened. Do not reference the timing marks marked on the timing gear to position the gear. In some applications, it may be necessary to slightly elongate the holes for the best bolt alignment. Look at the old cam gear to see if the holes were elongated. If they were, it may be necessary to elongate the new cam gear holes to match the fit. After finding the correct position, clean the threaded holes in the camshaft with cotton swabs and acetone and install each bolt snug. Do not over-tighten. Remove one bolt at a time and apply red Loctite number 271 to the threads. Reinstall the bolt and torque to 18 foot-pounds. Repeat this procedure with the other two bolts. Paint or make an index mark on the camshaft gear tooth that is positioned between the marked teeth of the crankshaft gear as shown. Remove and replace the old oil galley O-ring. Clean all the silicone from the mating surfaces of the engine case and the lower cover. Remove the oil in the lower cover and wipe it clean. Apply lithium grease to the teeth of both gears. Keep the mating surfaces of the case free of this grease. Apply a small amount of RTV 735 silicone sealant to the main oil galley O-ring groove in the case to help hold the O-ring in place. Install the new O-ring in the groove. Apply a small bead of silicone to the engine case or lower cover around the perimeter. Avoid excess sealant around the O-ring sealing area. Rotate the oil pump shaft in the lower cover to align with the camshaft slot. Install the lower cover, locating the dowel pins and the dowel sleeves. It may be necessary to tap the cover into place with a plastic hammer. Caution, do not use excessive force when hammering the cover in place. If the cover does not tap into place easily, check the alignment of the oil pump shaft and cam slot. Install the bolts. Torque the bolts to 15 foot-pounds. Wipe away any excess silicone sealant. Reinstall the engine. Refer to the 1,000-hour service interval for engine replacement. Replenish the engine oil and remember to prime the oil pump before starting. Refer to the engine manual for more information on oil pump priming. Wait a minimum of 10 hours before starting the engine to allow time for the silicone and Loctite to dry. Note, on initial startup after installing the steel gears, you may notice more noise than normal coming from the bottom of the engine. This is normal, and as the new steel gears break in, this noise will dissipate. Loosen the 5/16" nuts on the tension rods enough to remove the idler pulleys from the mount scissors. Remove the pulley by removing the bolt. Remove the two bolts that attach the idler pulley assembly to the tail boom and slide the idler pulley mounting scissors down and out of the tail boom. Remove and discard the temp strips. Replace with new ones after bearing replacement. Inspect for wear and anodizing on the pulley. Inspect and clean the scissors brackets and the area on the bulkheads where the scissors mount with acetone and cloth. Inspect the scissors and bolts for wear. Replace the lock nuts. Place a small amount of grease on each of the mating surfaces and the bolts. Tighten the nuts on the bolts just enough to allow the scissors to swing freely. The bearings in the tail rotor idler pulleys have a recommended changeout of 250 hours. New bearings are included in the 250-hour kit. Follow these procedures to replace the bearings. Remove the two snap rings. Heat the pulley in an oven 225 to 275 degrees Fahrenheit. Caution, do not exceed 300 degrees Fahrenheit, or the heat treatment of the pulley will be affected. Use appropriate tools and fixtures to press out the old bearing. When using a press, press only in the outer race of the bearing and not the inner race. Let the pulley air cool, then clean the inner mating surface with acetone. Install one snap ring. Heat the pulley to 225 to 275 degrees Fahrenheit. Apply a thin, even film of Loctite 609 to the outer surface of the bearing only. Remove the pulley from the oven and drop the bearing in place. If a press is necessary, use light pressure to ensure contact of the bearing to the snap ring. Wipe off remaining Loctite. Install the second snap ring and let the assembly air cool. Check to see that both snap rings have seated completely and that there is no play between the bearing and the pulley. Make an index mark on one tail rotor blade and the barrel. Remove the tail rotor blades. The index mark is necessary to ensure proper tail rotor balance upon reassembly. Remove the tail rotor assembly. Remove the belts. The tail rotor drive belts have a recommended change-out of 250 hours on condition or every 2 years. 3 new drive belts are included in the 250-hour service kit, 2 118-inch belts and 1 112-inch belt. The tail rotor shaft bearing assemblies are a 250-hour recommended change-out and are included in the 250-hour service kit. Remove the bearing slider plate from the bearing assembly. Loosen the set screws in the lock rings and use a hammer and a drift punch to unlock the rings. With a bearing puller, remove the bearing from the shaft as shown. You may need to heat the bearing's inner race to free the bearing from the shaft. Do not apply heat directly to the tail rotor shaft. Deburr the shaft where the lock ring set screw marked the shaft. Clean the shaft with acetone. Index the pulley, shaft, and bolt before removing. Remove the bolt from the pulley and slide the pulley off the shaft. Use a file or sandpaper to remove the burrs from the shaft bolt holes and set screw of the lock ring. Scotch-Brite also works good to remove any burrs from the shaft surface. use a bearing puller or press to remove the other bearing. Inspect all the other parts of the tail rotor for wear and proper end play. Install the new tail rotor shaft bearings and reassemble the components. Use Loctite 609 retaining compound to secure the bearings to the shaft. Reassemble according to the original procedures as outlined in the construction manual and video section 6 and reference prints E17-2000 and E17-2001. Install the tail rotor idler drive pulleys and the new belts and replace the 3/8-inch AN lock nuts with the new ones. Rotate the idler pulleys on the new bearings and check the field with your fingers for smoothness and ease of rotation. Refer to tail rotor belts break-in procedures in the construction manual and the first hour service interval of the maintenance video series. The cooling system hoses and the thermostat require replacement at 250 hours on condition or every 5 years. The 250-hour kit includes the replacement hoses and thermostat. Note, Rotorway recommends testing the coolant every 12 months. Replace the coolant every 250 hours or 24 months. Late model exec 90 and early exec 162f owners may want to retrofit their cooling system to the reverse flow cooling kit. This retro kit will provide improved cooling, especially those flying in hot ambient temperatures. Contact Rotorway's parts department for more details. It is extremely important to follow the cooling system bleeding procedures outlined in the engine manual and use only the recommended type of coolant. Failure to follow these guidelines could result in overheating and corrosion problems that may severely damage the engine and cooling system. Always replace the thermostat, engine coolant, and hose clamps when installing the new hoses. Caution, use only a Rotorway supplied thermostat for replacement. The correct type of thermostat was determined after many hours of testing at the factory. Use of the wrong thermostat could damage the engine cooling system. If the helicopter is stored for a long period of time without operation, place a small amount of oil, number 10W non-detergent, on the water pump shaft seal. The 3/4-inch main drive pin is replaced every 250 hours. A new drive pin is included with the 250-hour service kit. Follow the procedures outlined in the maintenance videotape 3 on main drive pin inspection. It is located under the 100-hour service interval for the rotor hub. This concludes the 250-hour service interval. Remember to include the 25 and 50-hour service procedures with the 250-hour service. Note, the following maintenance items are to be performed every 500 hours. To assist in performing the 500-hour service on your helicopter, Rotorway provides a 500-hour kit that includes all the parts required for recommended 500-hour changeout. In addition to the 500-hour parts, the 500-hour service kit includes all the parts for the 100 and 250-hour recommended changeouts. Call the Rotorway Parts Department for more information. The 500-hour service interval requires the cylinder heads to be overhauled, replacement of the main drive pulley bearings, the replacement of the main drive belts, and several other drive component bearings. All these items can be serviced while the engine is mounted in the airframe. However, you may find it easier to perform these procedures with the engine removed from the aircraft. If you decide to remove the engine from the airframe, refer to the 1,000-hour service interval in the maintenance video series for engine removal procedures. While the engine is out of the helicopter, Plug the fuel lines, oil lines, and coolant hoses to prevent any contamination. Note, if your helicopter uses 100 LL aviation fuel on a regular basis, Rotorway recommends reducing the overhaul time of 500 hours to 250 hours. Call Rotorway customer service for more information. Specifications have been given to perform this service, and all of the necessary parts are available from the factory. However, the overhaul is a critical and complex task and should not be attempted by anyone who is not familiar with all the aspects of aluminum cylinder head rebuilding. As an option, the owner-builder can remove the cylinder heads from the engine and return them to Rotorway for overhaul. Note, it is possible to remove the cylinder heads from the engine without removing the engine from the helicopter. However, in this demonstration, the engine has been removed for clarity of the procedures. To remove the cylinder heads, proceed as follows. Remove the valve covers. Loosen the coolant hose clamps and disconnect the hoses from the cylinder head fittings. Be prepared for an amount of coolant to drain from the cylinder head and water jacket when removing the bottom hoses. Remove the hex bolts that hold the intake manifold to the cylinder heads. Use a 6-inch, 1/4-inch ball hex bit to remove the two inboard bolts as shown here. Back off these two inboard bolts equally for their removal. Be sure and support the intake manifold assembly as you remove the bolts. The cylinder head on the passenger side has the water temperature sensor. It will need to be disconnected from the wire harness plug. Fabricate a block of wood numbered for the cylinders as shown. This is to store the push rods, rocker arms, and poly lock nuts in their correct orientation while removed from the cylinder heads. Also use a block of wood to hold the cylinder head bolts. Position cylinder 1 at top dead center. This will be useful when you reinstall the cylinder heads after the overhaul as a reference for setting the valve lash. Avoid disturbing the crankshaft position from this point on. Remove the polylock nut assemblies and rockers and place them in the wood block. Remember to loosen the set screw first, then back off the nut. This will prevent the polylock nut from backing out the rocker stud. Carefully remove the push rods and be sure to place the engine end of the rod in the wood block, so upon reinstallation you will replace the rod in its correct orientation. Using a breaker arm, follow the bolt torque pattern in reverse to loosen the cylinder head bolts. Loosen each bolt a quarter turn. Then continue loosening all the bolts equally. Then, after all bolts have been loosened, remove all but the two most inboard bolts. Leave one inside the rocker arm area and one between the intake ports. Slowly and alternating back and forth, loosen the two bolts as shown. You will notice the springs in the push rod tubes will push the cylinder head away from the engine. Carefully support the cylinder head as you remove the bolts. Remove the cylinder head. Remove the push rod tubes and set them aside. Carefully remove the compression seal O-rings. These are hollow rings and are made of stainless steel. To remove the rings, use a pick to carefully puncture the ring and rotate its position. The ring should work loose. Use caution so as not to damage the surfaces of the groove. Carefully pack the cylinder heads and return to Rotorway for service. Call customer service regarding cylinder head service and scheduling. Reinstall the cylinder heads as follows. Clean and inspect the pushrod tubes and springs for damage or corrosion. Replace if necessary. Clean the mating surfaces of the engine and cylinder heads with acetone. sure to clean the grooves of the cylinder sleeves before installing the rings. Never use a silicone or any other sealant on the compression rings or on the mating surfaces. Remove the pushrod tube seals from the crankcase. Clean and remove the silicone from the ports and the crankcase covers for the pushrod tubes. Use caution as you clean the ports to prevent the old pieces of silicone from falling into the crankcase. Note, the pushrod tubes, the ports in the crankcase, and the ports in the cylinder heads must be thoroughly clean and free of any oil before applying the silicone sealant. Use a cloth and acetone to thoroughly clean these areas. Inspect and clean the bolt holes in the water jacket. Use a cotton swab and acetone to clean the bolt holes. Pre-check the thread quality and installed bolt depths by applying a film of anti-seize to the bolts and thread them in the corresponding water jacket holes. Install new compression seal O-rings. To help hold the rings in place, very lightly squeeze the rings to make them slightly out of round. Place the ring on the groove and force into position using your fingers as shown. Note, this is a close tolerance fit. Verify the engine is at top dead center for cylinder 1. Carefully position the cylinder head and install all 8 bolts. Remember to reconnect the engine block ground wires when installing this bolt. Verify as you install a cylinder head that the compression rings stay in place. Use the socket with an extension to hand snug the bolts. Repeatedly torque all bolts, following the proper sequence, to 10 foot-pounds until none of the bolts move at this torque. Reference the engine manual for the proper cylinder head bolt torque sequence. Torquing the bolts to 10 foot-pounds will take several passes. Be sure all bolts are torqued at 10 foot-pounds before going to the next torque setting. Repeat this process at 14, 18, and 22 foot-pounds. Note the following assembly is for pushrod tubes with external springs. The procedure for the internal spring type is slightly different. Reference your engine manual for the replacement part numbers. Thoroughly clean the old silicone from the pushrod tubes. Use a piece of plastic to scrape the old sealant from the ends of the pushrod tubes. Replace the pushrod tube O-rings. There are two different O-rings per pushrod tube. Part number A24-4251 is for the red O-ring, and A24-4252 is for the black O-ring. Assemble the pushrod tube, spring, and retainer. Coat the O-rings with lithium grease and install the O-rings as shown. Note the black O-ring goes on first. Apply a liberal amount of grease between the O-rings. Replace the pushrod tube seals. There are 2 seals per pushrod tube, part number A24-4204. Use Dow Corning RTV Sealant 735 to seal the pushrod tube seals end ports. Be sure to clean the seals with acetone before installing. Remember, before applying the silicone, the area must be clean and dry. Apply a small amount of sealant to the pushrod tube end and install the seal. Place a bead of sealant on each seal and install. Compress the pushrod tube assembly and position between the crankcase cover and cylinder head ports. Make sure the silicone sealant is seated completely around the pushrod tube and seal. Before installing the push rods, verify they are straight and the ends show no sign of damage. Rotate the engine counterclockwise from its reference position, cylinder 1 at top dead center, to position the slots in the flywheel inline where the engine's center line is shown. Before installing the push rod, dip each rod end in engine oil. Install the corresponding rocker arm and polylock nut in the exhaust valve of cylinder 1. Now do the same for the intake valve of cylinder 4. Set the lash on these valves to tolerance 4 thousandths to 6 thousandths. Rotate the engine counterclockwise another 180 degrees. Align the slots. Install the push rods, rocker arms, and polylock nuts on the intake valve of cylinder 3 and exhaust valve of cylinder 4. Set the lash. Rotate the engine counterclockwise another 180 degrees. Install the push rods, rockers, and polylock nuts on intake valve cylinder 2 and exhaust valve cylinder 3. Set the lash. Rotate another 180 degrees and install the rods, rockers, and polylock nuts on the intake of number 1 and the exhaust of number 2. Set the lash. Rotate the engine 2 full turns and verify the lash adjustment. Check the lash adjustment of all 8 valves. Note, it will be necessary to make valve lash inspection after the first hour of operation. It is advisable to monitor the lash adjustment during the first several hours of operation after overhauling the cylinder heads. Replace the intake manifold gaskets and reinstall the intake manifolds to the cylinder head. Torque the bolts to 12 foot-pounds. Replace the coolant hoses and the clamps. Replace the fire sleeve hose if needed. Inspect the crankshaft end play. This can be done by attaching a steel plate to the engine and mounting an indicator on a magnetic base as shown. Measure the end play of the crankshaft. The standard amount of end play is between 4 thousandths to 6 thousandths. The tolerance for maximum end play is 14 thousandths. The 500-hour service requires the replacement of the engine's main drive pulley bearings. Verify the location of the index mark on the engine pulley and flywheel. Remove one spark plug from each cylinder. Be sure to clean the area around the spark plug before removing. Before removing the pulley, verify the runout of the pulley when rotating the engine. With the engine out of the airframe, the indicator should contact the pulley on the inside surface approximately 150 thousandths from the top of the pulley. This is the most accurate position to determine runout of the pulley. This is especially true on earlier exec models. However, with the engine installed in the airframe, it is possible to position the indicator on the outside surface as shown. The total indicated runout reading must be 4 thousandths or less. Note your reading for comparison later when reinstalling the pulley. With a 5/16" hex bit, loosen the 3 bolts that hold the pulley assembly to the engine crankshaft. Use the flywheel tool to hold the engine while breaking loose the 3 bolts. Remove the pulley assembly from the engine. Note the index mark on the flywheel and drive flange. These must be lined up on reassembly. Bearing replacement is a service offered by the factory. Call Rotorway customer service for more information. After bearing replacement, clean all surfaces of the parts to be reassembled. Clean the bolt holes and the threads of the bolts. Place the flywheel on the drive flange, aligning the index marks. Align the index marks and carefully lower the pulley onto the flywheel. Insert the washers and bolts. Snug the bolts. Rotate the flywheel clockwise against the bolts. Rotate the pulley counterclockwise against the bolts. This positions the flywheel and pulley accordingly when the load of the starter and drivetrain is applied. Torque the bolts to 28 foot-pounds. Using the same setup as shown before, check the runout of the main drive pulley. The total indicated runout reading must be 4 thousandths or less. If it is not, check to make sure the pulley and the flywheel index marks are aligned. If the runout is out of tolerance, try repositioning the pulley on the flywheel. If it still runs out too much, a shim will have to be added between the pulley and the flywheel in order to correct the problem. Once the pulley meets the runout requirement, remove and replace the bolts one at a time using Loctite 242. Note, removing, applying Loctite, replacing, and retorquing the bolts one at a time should not change the runout, but recheck the reading just to be sure. Because the helicopter operates in many different terrains and will experience a variety of landing conditions, the landing gear skid will remain an on-condition inspection item. Be sure the tail boom support braces are reinstalled before performing the frame and skid inspections. Lift the front skid off the ground approximately 10 inches and block it up with 2x4 boards. Look for a flat wear area across the bottom of the skid. If a hole exists, replace the skid. If a flat wear area measures more than 1/2 inch in width, replace the skid. Using a hoist to help support the helicopter, remove the 2 front skid shoe bolts. Part number E00-2414, a front skid shoe, and drop the skid 3 inches below the shoe. Check the holes for an oblong condition and for any cracks in the skid tube. Also inspect the bolts for wear prior to reinstalling the skid on the landing gear shoe. Inspect skid tubes under the other shoes. Use the following procedure to remove the tail rotor blades and pitch pins. Note several tail rotor parts are changed out at the 500-hour service, which also include the 250-hour parts. A new tail rotor blade assembly, bearings, and the hardware are included in the 250 and 500-hour service kit. Warning, only tail rotor blades manufactured by Rotorway International have a RCO of 500 hours. If you are disassembling the tail rotor for inspection and are not replacing the blade assemblies, follow the procedures in the maintenance manual regarding the indexing of the parts for reassembly so tail rotor blade balance will be maintained. Remove the two bolts that hold the blade to the pitch pin. Carefully grasp the tail rotor blade and barrel with your hands and rotate while pulling outward. Remove the tail rotor shaft bearings, tail rotor pulley, and carriage slider assembly as shown in the 250-hour service interval. Remove the snap rings and deburr the snap ring hole if needed. Grasp the pitch pin and pull it out of the barrel. A slide hammer may be fabricated to facilitate the removal of the pitch pin. The pitch pins and blade assembly, snap rings, alignment bearings, thrust bearing assembly, and O-rings are replaced at the 500-hour service interval. Carefully remove the snap rings from the barrel. Be careful while doing this procedure not to mark or scratch the inner surface of the tail rotor barrel. Remove this bolt from the tail rotor barrel. Use a thin-bladed tool to pry under the lip of the bearings, removing the bearings from the barrel. Inspect the tail rotor shaft for wear. Inspect for corrosion and pitting of the surface. Inspect the key. Inspect the tail rotor barrel for damage and wear. At 500 hours, replace the bearings E17-1260 and the 3/8-inch bolt E00-2604. Note, when replacing the pivot bearing, they should fit tight in the holes and not turn within the hole. Use Loctite 609 to secure the bearings to the barrel holes. Reinstall the bolt, tightening it just enough so that the head of the bolt can be rotated slightly with your fingers. Check end play by using your hand and fingers, pushing the barrel from side to side to confirm proper end play. Replace the carriage bearing, part number E17-1300. Remove the snap ring. Thread the 2 bolts into the carriage bearing as shown. Heat the assembly in an oven to 275 degrees. With a press and the proper tool, press apart the 2 pieces. Now remove the snap ring. Press the bearing out of the housing. Clean the parts with acetone and replace the bearing. Use Loctite 609 to coat the outside of the bearing and inside the race. Reheat the housing and assemble the parts. Note, before final assembly, you must check the static balance of the replacement tail rotor blade assemblies. Refer to the tail rotor balancing procedures in Section 6 of the construction manual and video. Install the new tail rotor shaft bearings and reassemble the components. Reassemble according to procedures as outlined in the construction manual and video Section 6 and reference prints E17-2000 and E17-2001. The rubber main oil drain hose and the 2 rubber valve cover drain hoses need to be replaced on condition every 500 hours or 5 years, whichever is reached first. These hoses are included in the 500-hour kit. The radiator cap is a 500-hour or every 5 years RCO and is included with the 500-hour kit.